order up to model, how to set order up to level for different objectives using Excel. So in this video segment, I want to show you how you can set the order up to level based on either desired service level or to maximize expected profit. And the service level will be defined either as in-stock probability or the fill rate. So first, if you want to achieve a desired in-stock probability P, and if your demand has normal distribution, then all we need to do is find the inverse of the cumulative distribution function for the demand with the for the desired probability P. But remember, this has to be distribution of demand in L+1 time periods, right? So the inverse, we have to calculate it for mean and standard deviation that correspond to demand in L+1 periods. And remember also to round it up in order to overachieve the in-stock probability rather than underachieve it. So here is an example Excel file that can do the calculation. The inputs are expected demand in one period and standard deviation of demand in one period, mu and sigma. And the lead time is 3. In this case, if you recall, this was the distribution center assumptions. The period was one week and the lead time was 3 weeks. And so this is the calculation for demand during L+1 periods. This is the mean, this is the standard deviation. And if you want a desired in-stock probability 99%, we can calculate it using roundup of norm inv with the appropriate in-stock probability 99% and the mean and standard deviation for the demand during L+1 periods. Right, so this is 596. If we, for example, assumed 95%, it would be 516, and so on. If we want to do the same calculation when the demand has Poisson distribution, well, you cannot find the inverse of the cumulative distribution function because for the Poisson distribution, which is discrete, this inverse cannot be calculated usually. So what we need to do is we need to try and set S to the smallest value such that cumulative distribution function of the demand, again, demand in L+1 periods, is right. The probability is higher than the desired level P. So here is a calculation for the Poisson distribution in Excel. This is the input, the mean demand in one period. Remember, this was the Susan Magnotto's territory where period was 1 day. Demand per day was 0.29 units on average, and the lead time was 1 period. So the expected demand in L+1 periods was 0.58. Standard deviation is not calculated because this is Poisson distribution and standard deviation is always equal to square root of mean. So if the desired in-stock probability is 0.99, well, we have to set S to such a value that will give us this desired in-stock probability achieved or overachieved, right? Now I have created here on the right the calculation that does, right, first of all calculates takes the mean 0.58 and does the calculation for X for the quantity 0, 1, 2, and so on. What is the probability, cumulative probability, probability for X and cumulative probability distribution function for X, right? So here there is Poisson for the X with the mean mu2 in this case, mu in L+1 periods, and 0 means that this is just a probability, and here it's cumulative distribution function. So we can see that the calculations here actually, right, for X equal 2 or S, right, this could be S as well, is 0.978, so it's too low, but for S equal 3, it is high enough. Now, I programmed here a formula that automatically chooses S value, but you can always verify that S equal 3 here is high enough for this, right? And if we try, for example, 95%, then S equal 2 is sufficient, right? If we tried 80%, 0.8, S equal 1 would be sufficient. And let's see if we try 9996, then 4 is sufficient, but 3 is not, right? So this is the calculation for the order up to level based on Poisson distribution and assuming in stock probability is given. The second case is if we want to achieve a desired fill rate. And both for normal and Poisson distribution, the way to find the order up to level S that will satisfy a certain fill rate is just to increase or decrease service level S until fill rate achieves the desired value. So here I have this part of the spreadsheet is evaluating given service, given order up to level S, it is evaluating it and showing me that expected fill rate is 99.51%. And this fill rate is calculated from the expected back order, right? Expected back order and the average demand per period, in this case, per week in the distribution center. And so, and this, remember, is the normal loss function for a given value, order quantity, or in this case, order up to level, and the mean and standard deviation of demand in L+1 periods. So if I, let's say, I would like to have 99.9% fill rate, this is insufficient. I can try and increase it maybe to 600. It's still not 99.9. Let's try 700. It is much more, right? I can now try to divide 99.8, 660, 99.91. Maybe I can lower it a little bit. 655 is already achieving, and probably that's a good value. Now I have 99.9% fill rate. If I want to do the same calculation for the Poisson distribution, again, I have here a block of calculations that is evaluating the given order up to level S and finding the expected fill rate. And this expected fill rate, as before, is calculated based on the expected back order and average demand per period. Now, expected back order is based on a loss, Poisson loss function that is calculated here in the third, right, as a third function. And so basically, this is not really a calculation. This is just taking the appropriate value. So if S is equal to 3, this is picking up from row with S3, picking up the value that is the value of the Poisson loss function with this mean equal to demand, mean of demand during L+1 periods. So if I assume S is equal to 3, it is achieving fill rate, expected fill rate of 98.84%. Let's say I want 99.9, then I can try to increase it to 4, and it is still not 99.9, it's a little bit less. I can try 5, and now I'm way overachieving 99.9, but this is the smallest value I can assume. So S equal 5 would give me the desired fill rate. The third and final case is to try and set the order up to level S such that we maximize expected profit or minimize equivalently the expected mismatch cost. For that, we have to know the underage and overage costs. And cost of underage will be the cost of having 1 unit of back order per period, right? And then the cost of overage will be cost of holding 1 unit for 1 period, from 1 period to the next. When we do know those two costs, we can calculate the critical ratio and just solve the problem for in-stock probability equal to this critical ratio, as we did in the first case. So, right, again, different solution for the normal and different solution for the Poisson distribution. In addition, we can calculate the mismatch cost using the formula where we, for every unit of on-hand, expected on-hand inventory, we pay cost of overage, and every unit of expected back order, we pay the cost of underage. In Excel, we have this block that does the calculations, right? This is the cost of underage, assume here 50, overage 1. This is what calculates the critical ratio based on those two costs, and this is what sets the order up to level S based on the critical ratio calculated above, and of course the expected and standard deviation of demand during L+1 periods, because remember, S has to match the demand in those L+1 periods. So for this calculation, it is 565. Similarly, we can do the calculation for Poisson distribution. This block does the calculations. Here again, underage cost is 50 and overage cost is assumed 1. As an example, critical ratio the same as before, and now the order quantity, again, we have to choose S such that the cumulative distribution function is exceeding or equal to this critical ratio, which will be again 3. We can do the calculation for the underage and overage costs that we assumed in our example with gross margin 0.75 and the overage 0.000337. If you recall, these were the multipliers of the price, but actually the price doesn't matter for the ratio, so these can be assumed as costs. And you see that order quantity for Susan should be then 4 if we want to optimize, maximize profits, right? When lost profit from having underage is 0.75 and holding cost per unit is this very small value. The order up to level should be 4.